In this video, we're going to discuss tuples, their immutability, as well as packing and unpacking. A tuple is a standard sequence similar to a list, but it's defined using parentheses rather than square brackets. Tuples can contain any data type. For example, we could create a tuple T containing a couple integers and even a string like hello. Now, if you need to create an empty tuple, that is a tuple that contains 0 elements, then you simply use a pair of empty parentheses. So I'll say empty equals to parentheses. And then just to show you that this is indeed a tuple, I'm going to print its type and its length. And so you see that it's a type tuple, and of course the length is 0. And if we print the tuple, you'll see that we get the empty pair of parentheses printed as well. Now, interestingly, if you were to create a tuple containing a single element using only parentheses, you're going to find that this doesn't work. Notice here that the type is string and that the parentheses were removed in the output. And on top of that, if we were to print the length, we get 5 back and not 1 as we had hoped for a single element tuple. And that's because Python can't differentiate at this point whether you want a single element tuple or you want to evaluate an expression within the parentheses. So in this case, it just assumes that it's an expression. In the previous case where we had an empty tuple, there are no expressions to be evaluated in between the empty parentheses, so it knows that you wanted an empty tuple. Now to create a single element tuple, we actually have to add a comma following our element so that Python can differentiate between these two cases. And now the output actually looks correct. Here we have type tuple, and you see the parentheses and the comma exist in the output of the tuple itself. And of course, now if we were to get the length of this tuple, you'd see that we get the result 1. And just like with lists, tuples can be indexed using the square bracket syntax. So the following, t square bracket with 0, accesses the first element of the tuple t. Likewise, we can use slices, just as we did with lists. So t with 0:2 returns the first 2 elements of our tuple t. Now, since we've already gone through indexing and slicing in somewhat duplicate fashion with the introductory strings and list notebooks, we're not going to repeat all of that here since the mechanics and the caveats are really the same. So if you need a refresher on any of that, I would recommend looking back at the list notebook for the sections on indexing and slicing. Of course, keeping in mind that the only difference should be that slicing a tuple returns a tuple and not a list as it did with the list notebook. So we already know that tuples can contain any type, and that does include other tuples, so we can nest tuples like so. We'll create a new tuple, the first element of which will be t, our previous tuple from above, and then maybe the next element will be another tuple containing the integers 1 through 5. Now, unlike lists, tuples are immutable, and that means that once they're created, they cannot be changed. So if I recreate our tuple t, and then attempt to set the element at 0 to a new value, you'll see that we get a type error stating that the tuple object does not support item assignment. And again, that's because tuples are immutable. Now, tuples can contain any type of object, which does include mutable objects. So what happens if we create a tuple that contains mutable elements? So far there's no problem. We were able to create a tuple that contained 2 lists. Now, what happens if I try to modify one of the lists within this tuple? I'll say v, and we're going to select the first list, which is the element 0. And then maybe we want to modify the second integer in that list. So I'll say index 1, and we'll just set it to a value like 15. And we'll output the tuple. And we see that the list inside the tuple was indeed modified. But why? Well, the tuple itself is immutable, meaning that it will always point to the same 2 lists that were used to create it. The lists, on the other hand, are mutable, meaning that their contents can be altered. But they are still the same list objects. So even though we modified the state of the first list here, we did not modify the state of the tuple, so the operation was allowed. Okay, so if I copy this first example here, and this time we're not going to use parentheses. When I output t, you see that we still get a tuple. And that's because the assignment of a comma-separated list to a single value is understood to be the packing of the elements on the right-hand side into a tuple that will then be bound to the name on the left-hand side. So the 3 elements I have here, 2 integers in the string, are packed into a tuple, and that tuple is then bound to the name t. The opposite of packing is unpacking, And this works similarly. So if I write X, Y, and Z separated by commas, and then bind those three names to the tuple T, each of the elements in T will be assigned to a separate value, X, Y, Z. And if I print them out here, you'll see that that's occurred. X and Y are bound to the first two integers, and Z to the string hello. Now, unpacking will maintain the order of the elements in the tuple. So the first element is assigned to the X, the second to the Y, and third to Z. Also, unpacking is not going to work if you give a different number of names on the left-hand side than there are elements in the tuple on the right. So those do have to match.